Hey guys, we are on GCSE Trigonometry revision and we are going to consider 3D problem solving. That's about pyramids. So that's the actual real-life application of trigonometry. And let's have a look at the example. Pause the video, try to do it by your own, and we get started. So this is the model, what you can see here on the picture, of the lamppost D. So D is right there. That's the vertical segment, which is 6.8 meters in length and stays vertically. So vertically means perpendicular to the ground, with 3 supporting cables, AD, BD, and last CD is right there. Okay, you can see basically the edges, slant edges of their pyramids. All equal in length and holding it against the wind so that the angle of elevation to the top end of the post is 50 degrees. So where is the angle of elevation? It's the angle between each string or each cable and projection on the base. So the base in this case is A, B, C is the ground. So that's why, for example, here's this 50 degrees angle is between AE, which is the shadow that DA casts, the cast from D, if the line resonates from the vertical, from the top, in a vertical way. Okay, so, and triangle ABC is on horizontal ground. So it means all 3 points are on horizontal ground, and that means ABC lays completely on the ground. So it's flat, and that's what represents the horizontal plane. Okay, what do you need to find? You need to find the total length of the cable used for those 3 strings supporting that lamppost. Alright, so we understand that's the picture. It's already like it's shown in the problem. Otherwise, it would be hard to imagine how it looks like. So let's consider. Actually, applying trigonometry to 3D is always the case when you're looking for flat triangles. In this case, you need to find triangles that will give you the ratio, so you can apply the ratio there and find unknowns. Okay, so what we need to find? We need to find the length of any cable, because all cables the same, so definitely triangle ABC is going to be equilateral, right? And we have D, which is perpendicular to that plane where triangle ABC lays. Okay, we also know that all cables all equal in length, so that means all edges are the same. So that's why we need to find just one edge and multiply by 3. Let's figure out which triangle to use. So for example, let's have a look at triangle ADE. So let's consider triangle ADE. It's definitely a right angle, so we can fix that it's right angle. Right angled triangle. And where is the right angle? It's right there. Okay, that's E in this case. So we have angle 50 degrees. Let's say angle theta, it's 50 degrees there. We need to find AD. Let's set up as X. And we have D, which is equal to 6.8 meters. So we have opposite side and we need to find height. Okay, this is height. We have D as the opposite side to the angle 50 degrees, so we can set up sine rule. So sine 50 is going to be opposite to height, or from there it's better to use opposite equal to height times sine of angle 50 degrees. Okay, so from there we can figure out that unknown is height, so we can plug the values. 6.8 is equal to x times sine of 50 degrees. From where we can figure out x. X is going to be 6.8 over sine 50. Go to calculators and try to figure out. So going back, and we calculate 6.8 over sine 50. make sure you have a degree mode on your calculator. And here we go. We've got the value 8.88 meters to 2 decimal places. Okay, so that's the final solution. Almost there, because the total length of the cable, so total length of the cable is going to be right times 3, right? One more time, 3 times 8.88. We've got 26.64 meters, 2 decimal place. And that's going to be the final answer. I just highlight with the yellow, and here we go. We've got the final answer for our solution for our question, find the total length of the cable used. Hope you liked that. Hope you understood. So no problem with that. That was Daniel Dallas, and see you later.